Hi, I am Syed on Maths Online. Today we will be discussing about properties of Laplace transform. So let us start with the first property. If L of f of t, the Laplace transform, can even be represented in the form of f bar of s, then in that case the Laplace transform of e power of at f of t can be written in the form of f bar of s minus of a. So that's the property we have. If L of f of t is f bar of s, then the Laplace transform of e power of at f of t can be written as f bar of s minus of a. So we are just shifting this value of s over here to s minus of a. Therefore this property is also called as shifting property. So let us take few examples based on this property. So let us find the Laplace transform of L of, so the first question is e power of minus of 3t into, it is 2 times of cos of 70 minus of sine of 70. So if we try to compare this result, it is in the form of e power of at, which is e power of at form, and this entire expression, that is f of t, will be acting in this form. So if I take the value of f of t to be equals to this particular value, 2 cos 70 minus sine 70. So in that case, let us take the value of f of t to be equals to, it is 2 cos 70 minus of sine of 70. So if I take the Laplace transform on both the sides, I will be getting Laplace transform of f of t will be equals to Laplace transform of the whole function, is 2 cos 70 minus sine of 70. So if I apply the Laplace transform individually, first term 2 I can take constant and write Laplace transform of cos of 70 minus, apply the Laplace transform for the next term, it is Laplace transform of sine of 70. So we know the basic formula for is cos of 80. This formula is known to us. We know Laplace transform of cos of 80. Its formula is s by s square plus a square. And we also know the formula for sine of 80. So the formula is a by s square plus a square. So if you use these two formulas, I will be getting the value as Laplace transform of f of t is equals to, it is 2 times of cos 70 can be written as s by s square plus, here the value of a is 7, so we will be getting 7 square, minus of, you have Laplace transform of sine 70 will be, a value is 7 divided by s square plus 7 square. Further simplifying this one, this becomes 2s by s square plus 7 square is 49 minus of, it is 7 divided by s square plus 49. So you got L of f of t. The moment I include that value of e power of e power of, we have minus of 3t f of t. So this particular value which is there, this L of f of t that we have over here can even be written in the form of f bar of s. So if L of f of t is f bar of s, we know the property over here, L of e power of at, this particular value. The moment you include this e power of at, this value of f bar of s will become f bar of s minus of a. That means the value of s will shift from s to s minus of a, this particular value a. So where is this a value? A value is this power of e power a times of t. So therefore now over here, if I want to write down f bar of s is already there over here. F bar of s is already there. Because I have included this e power, s has to be shifted to s minus of a. So s has to be shifted to s minus of a. So what does this a represents? As I told you, a represents this coefficient of t value. So coefficient of t value is what? The value of a in this case is minus of 3. So s will be shifted to s minus of a value is minus of 3. So therefore this becomes s minus of minus will be plus 3. So you have to shift s to what value? S plus 3. So now this expression will be the same to s by s square plus 49, whereas the second term will be the same, s 7 by s square plus 49. Whereas this whole expression s is being shifted to what value? S plus 3. S will become s plus 3. So now I have to change that value on the right hand side. Wherever s is there, replace the value of s as s plus 3. So 2 times of s plus 3, its whole divided by s plus 3 whole square plus 49 minus of, it is 7 by s will become s plus 3 whole square plus 49. So we have got this Laplace transform of e power of minus of 3t. I have already taken the value of f of t to be equals to how much? 2 times of cos of 70 minus sine of 70. So that will be the required solution. So this set of problems are similar to the problems what we have done in the previous video. So as usual, you need to find out the Laplace transform of whatever the function is. So this is the function. So we are just finding out as usual the normal Laplace transform till here, normal procedure. But here, because you are having e power of t value over here, because of this e power of t, what will happen to the solution that you have got over here? So this solution, for this particular solution, you have to just shift the value of s to s plus 3 based on this value of a. Alright. So based on this value of a, you have to shift s to s plus 3 and write down the final solution. I hope you have got this procedure. Now let us try with another example. So find Laplace transform of e power of minus of t into cos square of 2t. So this particular value which is there, this is in the form of e power of at into f of t. So this will be acting as your f of t value. So here your value of f of t is nothing but cos square 2t. So we know the formula for cos square of t to be equals to 1 plus cos of 2t divided by 2. Trigonometric function formula, cos square of t is nothing but 1 plus cos 2t by 2. So if I use that formula over here, I will be getting 1 plus cos of 2 times of. So here you are having t value, but in this case it is 2t. So therefore this t value has to be replaced by 2t. So 1 plus cos of 2 times of 2t, this whole divided by 2. So therefore you will be getting the value as 1 plus cos of 2 times of 2 will be 4. So it is 4t divided by 2. So the square term which was there for cos, I have eliminated that. So I got 1 plus cos of 4t divided by 2. So we'll try to apply the Laplace transform on both the sides. Laplace transform of f of t will be equals to Laplace transform of 1 plus cos of 4t whole divided by 2. So divided by 2 is a constant, you can take that outside. Apply the Laplace transform for the first term in the numerator is 1 plus Laplace transform of the second term is cos 4t. So we know the standard formula which will be equals to, this is 1 by 2 as it is Laplace transform of a is a by s. So Laplace transform of 1 will be 1 by s plus Laplace transform of cos at is s by s square plus a square. Here the value of a is 4, so therefore you will be getting 4 square. So this can be further written in the form of 1 by 2 times of 1 by s plus s by s square plus 4 square can be written as 16. So it is s square plus 16. So this will be acting as your f bar of s value. L of f of t is nothing but your f bar of s. Now I will try to include that e power of. So if you try to see in the example, the value of this e power of minus of t you have. So therefore if I try to include that e power of minus of t, it is e power of minus of t into f of t. So the moment you include e power, you have to shift the value of s to s minus of a form. So right hand side will remain as it is. I'll write it as it is. 1 by s plus s by s square plus 16. You have to shift s to s minus of a. So what is the value of a here? So the value of a in this case is minus of 1. So you have to shift s to s minus of a. So it is s minus of a value is minus of 1. So therefore it becomes s plus 1. Minus of minus will be plus 1. S plus 1. So you have to shift s to s plus 1. So if I try to rewrite this one, so wherever s is there, just put the value of s to be equals to s plus 1. So this will be equals to 1 by 2 times of 1 by s will be s plus 1 plus s will be s plus 1 whole divided by s will be s plus 1 whole square plus 16. So on the left hand side you have Laplace transform of e power of minus of t, and what is the value of f of t I have taken? I have taken the value of f of t to be equals to cos square of 2t. So that will be the required solution. Let us move on to the next question. Find the Laplace transform of e power of minus of 4t t power of minus of 5 by 2. So this is Laplace transform of e power of minus of 4t t power of minus 5 by 2. So once again it is in the form of Laplace transform of e power of at into f of t form. So therefore I will be taking this value to be equals to f of t. So f of t value we have, its value is nothing but t power of minus of 5 by 2. So we have to take the Laplace transform, simplify this result. So Laplace transform of f of t will be nothing but Laplace transform of t power of minus of 5 by 2. So I had already given you in the previous video the formula. Laplace transform of t power of n will be nothing but whenever the value of n is not an integer, we have the formula as gamma of n plus 1 divided by s power of n plus 1. So I will be using this formula. Here the value of n for this problem is minus 5 by 2. So therefore it becomes gamma of minus of 5 by 2 plus 1 whole divided by s power of minus 5 by 2 plus 1. So try to simplify that one. Minus 5 by 2 plus 1 will be minus of 3 by 2. So we'll be getting gamma of minus 3 by 2 whole divided by s power of minus of 3 by 2. So I need to find out the value of gamma of minus 3 by 2. So I'll take this as say equation number 1. So to find this value of gamma of minus 3 by 2, I had shown the procedure of finding out negative value whenever you have that under gamma function in the previous video. So you can watch my previous video to get the details of this negative function. However, for this problem I will be showing you when you have negative under the gamma function, the formula that you have to use is gamma of n to be equals to gamma of n plus 1 divided by n. So if you take the value of n to be minus 3 by 2, so it is minus 3 by 2 will be equals to gamma of minus 3 by 2 plus 1 divided by minus of 3 by 2. Or if I take that minus 3 by 2 in the numerator, it becomes reciprocal. It becomes minus 2 by 3 gamma of minus 3 by 2 plus 1 will be minus of 1 by 2. Minus 2 by 3 as it is. Once again, because it is negative, therefore once again the same formula has to be used, gamma of n to be equals to n plus 1 by n. So now the value of n is minus 1 by 2. So you will be getting gamma of n plus 1. So n value is minus 1 by 2 plus 1 whole divided by, this value is minus 1 by 2. Or further, if you try to simplify this expression, you have this negative of negative will become positive. So 2 by 3 as it is, 1 by 2 when it comes in the numerator becomes 2 by 1, and gamma of minus 1 by 2 plus 1 will be 1 by 2. If we try to multiply, you will be getting 4 by 3, and gamma of half is square root of pi. So we got the value of gamma of minus 3 by 2 as 4 by 3 into square root of pi. We'll try to plug in that back in equation number 1. So we get L of f of t to be equals to, so equation 1 implies L of f of t is equals to, it is gamma of minus 3 by 2 is 4 by 3 square root of pi whole divided by, it is s power of minus of 3 by 2. That is equation number 1. Now I have to include that e power. So Laplace transform of e power of. So what is e power value? In the question it is e power of minus of 4t. So in the question it is e power of minus of 4t into f of t. As you know, that is L of f of t in the previous step. Its value is nothing but f bar of s. So the moment you take this e power, right hand side you can write 4 square root of pi divided by 3. You can take in the denominator s power of minus 3 by 2. So the moment you include e power, in that case you have to shift the value of s to s minus of a. So what is the value of a in this case? A value is minus of 4. So this value you have, a value is minus of 4. So you are shifting the value of s to s minus of a. So s is being shifted to s minus, a value is minus of 4. Therefore it becomes minus of minus will be plus, s plus 4. So s will be shifted to s plus 4. So just replace the value of s as s plus 4. You will be getting the value as 4 root of pi divided by 3 into, it is s plus 4 to the power of minus of 3 by 2. If you want to write this in terms of the positive powers of s plus 4, you can rewrite this value to be equals to 4 square root of pi by 3 into, so this s plus 4, when it comes to the numerator, the power will become positive, s plus 4 to the power of plus 3 by 2. And left hand side you can write Laplace transform of e power of minus 4t as it is, and f of t value is nothing but your t power of minus of 5 by 2. So that's the required solution. Let us move on to the next question. You have to find the Laplace transform of sin h at into sin of at. So if you try to see this example is not in the form of Laplace transform of e power of at into f of t form, which is a standard property we have. So we need to express that in the standard form. So for that, I'll try to rewrite the sin h at. Basic formula is known. Sin h at can be written as e power of at minus of e power of minus of at divided by 2. So sin h at you got. But along with sin h at in the question, sin at is there. So I'll just multiply on both the side sin 80. So sin 80 I am multiplying on the right hand side. So I am multiplying sin 80 on the left hand side. Therefore on the right hand side also I have to multiply by sin 80. So we have sin of 80. So now 1 by 2 I will take that as constant outside. I will rewrite this value as e power of 80, multiply that by sin 80. First term. Then minus of, multiply the second term, e power of minus of 80, once again that is multiplied by sin of 80. Of t to be equals to 1 by 2. If you try to multiply it, you are getting it as e power of 80 sin of 80 minus e power of minus of 80 into sin of 80. So if you apply the Laplace transform on both the sides, we have Laplace transform of f of t is equals to, it is half times of, apply the Laplace transform, it is the Laplace transform of e power of 80 into sin of 80 minus Laplace transform of e power of minus 80 into sin of 80. So we know the property that Laplace transform of e power of 80 f of t can be written in the form of f bar of s minus of a, which means that s is being shifted to s minus of a. So what can I do over here is that I'll try to find out the Laplace transform of sine at separately. So what is the Laplace transform of sine at? So I can write this expression in the form of, say, Laplace transform of sine of at. So what will happen to this e power of at? So e power of at, as we know that when you have L of f of t, it is written in the form of f bar of s. But the moment this e power of at is included along with f of t, this s will be shifted to s minus of a. So what I am doing is, instead of writing e power of at f of t, I am writing the expression to be f of t. So in that case, what will happen to this e power of at? E power of at, s will be shifted to s minus of a. So I'm just trying to do this problem directly. Just to reduce the number of steps, you can use this method. So just leave this e power of at and then just write down Laplace transform of sine at. So this e power of at will be converted to s being shifted to s minus of a minus. Here also I will be doing the same process. Laplace transform of, I'll write down sine at as it is. What will happen to s? S will be shifted to s minus a. So what is the value of a over here? A is minus of a in this case. So minus of minus of a. So which means that we will be getting s minus of minus will become plus a. So s will be shifted to s plus a. So just rewritten it. Now apply the Laplace transform. 1 by 2 times of Laplace transform of sine at will be a by s square plus a square. So what is happening to this s? S is being shifted to s minus of a. I have written it as it is. Minus of. Here also sine at, its formula is a by s square plus a square. S is being shifted to s plus a. So now wherever s is there, just put in the first term s to be s minus of a. So it is a by s minus of a whole square, and this plus a square as it is. Minus of, it is a by. So in place of a in the second term, you know its value is s plus a. So you'll be getting s plus a whole square plus a square. Now further we need to expand this one. So if you try to expand this denominator value, we'll get the expression to be equals to 1 by 2 times of, it is a by. So it is in the form of a minus b whole square. So we'll be getting a square minus of 2 times of a into b. S into a or a into s plus b square. B square will be your a square value. Then this term plus a square will remain as it is. Then minus of this a value as it is whole divided by. Denominator you have s plus a whole square. So it is a plus b whole square form. It is a square plus 2ab or 2 times of as plus b square will be here a square plus the next term a square as it is. I just expanded it. Further simplifying, you will be getting the value to be equals to 1 by 2 times of, it is a by, it is a square minus of 2as plus a square will be 2 times of a square. Here minus of a by, this is a square plus 2as, again a square plus a square will be 2a square. So you can take the value of a common outside divided by this 2, and simultaneously I will be taking the LCM also over here. So the LCM in this case is a square minus of 2as plus 2a square, the first term. The second term, a square plus 2as plus 2a square. That's the LCM. You need to just cross multiply this expression. If we cross multiply this a square plus 2as plus a square here in the numerator, a is already taken, so just 1 is left out. So 1 times of a square plus 2as plus 2a square will be the same term, minus of. So this expression has to be multiplied over here. A is already taken out, only 1 is left out. So 1 times of this denominator will be the denominator itself, a square minus of 2as plus 2a square. Now further we'll try to simplify it. So if we try to simplify this expression, it will be equals to a by 2. You can see this a square and a square will cancel out. These two terms will cancel out. This a square and this minus of a square will cancel out. And this plus 2a square and this minus of 2a square. If you multiply this minus inside, minus 2a square will cancel out. So we will be left out with 2as, this particular term, and minus of minus plus 2as. So 2as plus 2as will be 4as. Whole divided by the denominator value. You can see that you have the expression as a square plus 2a square. I'll try to group it. A square plus 2a square. I'll just group that one. Minus of, I have 2as. This is one term. Another term in the denominator. Here also I'll try to group the same. A square plus 2a square together. So I'll be getting the value as a square plus 2a square. Then this plus 2as as it is. So it is in the form of a plus b into a minus of b. So which is nothing but a square minus of b square form. So just try to multiply this and also cancel out 2 1 times, 2 2 times. So we will be getting the expressions 2 times of a square. Yes. It is whole divided by the denominator is in the form of a minus b into a plus b, which is a square minus b square. So a value in this case is a square plus 2a square whole square. It is a square minus of b square. So b value in this case is 2as. It will be whole square. A square minus of b square. Or further, if you try to simplify this expression, this will be equals to, it is 2a square, yes, it is whole divided by. Now the first term is in the form of a plus b whole square, so you can expand it. A square plus, it is b square plus 2 times of ab. So 2 times of a into b value over here is 2a square. So it is a square plus b square plus 2ab minus, you can expand this one, it is 2 square will be 4, you will be getting a square and a square. Or further, if you try to simplify this one, it is 2 times of a square, yes, whole divided by. This will become square of square will become power 4. This is 2 square will be 4, you will be getting a power of 4. Here plus, you can multiply 2 times of 2 will be 4, a square, a square. Here minus of, again 4 times of a square, a square. So the last two terms, 4 a square and 4a square, positive and negative value will cancel out, and we will be left out only with 2 times of a square s whole divided by, it is s power of 4 plus 4 times of a power of 4. So that will be the required solution. So that's all I have for today. Thank you.